This video will discuss the properties of matter. So you can see here with our little 3 sub-bullet points, we're going to be just very briefly talking about the chemical properties, some physical properties, and how matter changes states. So we talked previously about how there are 4 states of matter: solid, liquid, gas, and plasma. So those are actually somewhat interchangeable, and we're going to discuss that today. So chemical properties, and again, this is just a brief overview. You will discuss this more in 9th grade science, and then if you continue on into chemistry, just specific chemistry, then you will discuss it in greater detail. So for right now, we're just talking vague details. So chemical properties describe how one substance changes when it reacts to another substance, with other substances. So when you think of the stereotypical a chemist or someone who does chemistry, you might think of her, the scientist, pouring 2 different solutions into a beaker and then they explode. That is a chemical reaction. That's a chemical property of those solutions. It's going to allow it to react. Okay, so that's what we're talking about here when we're talking about chemical properties. The chemical properties of iron cause it to rust when it reacts with water and oxygen, just like matter here. Iron has the ability to what's called oxidize, comes from that word oxygen, and it actually begins to rust. So most likely here, matter, way back in the day, he was nice and shiny and metal looking, and now he's all rusty. Okay, so that's one of the properties that are chemical properties related to iron. Physical properties are easier, in my opinion. Physical properties are things that you can observe without changing a substance into a new substance. So the textbook that I looked at talked about, way down here. Talked about your blue jeans or whatever pants you're wearing. You can observe that they're blue, you can observe that they're soft-ish, and they might be about 30 inches long depending on how tall you are. That's an average. Okay, so in a comparison, chemical properties are when one substance changes. Physical properties, you're not changing anything. The physical property of water is that it is wet, it's clear for the most part. Water is mostly odorless. The physical properties of air, it's definitely clear. Unless you're standing around something smelling good or something stinky, it's odorless. Okay, so physical properties are easily visible. We have already talked about density, and we did that so that it made more sense here. Density is a physical property of matter, so it's something we can physically look at without changing anything. So just as a review, density is the measure of the amount of mass in something divided by the volume. So you have that formula, density equals mass divided by volume. So when we did those labs, we didn't change anything. We just put that object into some water and we observed it. That's a physical property. So more dense objects will sink, lower density objects will float. Here in this cup, what we have is some water down here on the bottom, and then we have oil on top. So water has a density of 1 gram per milliliter. Oil has a density of 0.9 grams per milliliter. So that means that it is less dense. So right here, lower density objects will float. So the oil actually floats on top of the water. Here's where we're talking about changing states of matter. So a little bit of a jump. Matter can change states, such as solid, liquid, or gas, when it either reaches its freezing point or its boiling point. Both of those may sound vaguely familiar to you, but we're going to talk about them all a little bit more, or both of them a little bit more here. So matter changes from a liquid to a solid at its freezing point. Think about a hot summer day and you have soccer practice and you know it's going to be a scorcher out there. Okay, you might put a bottle of water into the freezer. That changes it from a liquid to a solid because it has reached its freezing point. Okay. The opposite, matter changes from a liquid to a gas at its boiling point. Think of boiling water for mac and cheese. As you add more and more heat, it gets hotter and hotter, and some of the water actually rises up and escapes as that steam or as gas. Okay, so this little figure down here showing, as you get colder, it turns solid. As you get more heat, it turns into a gas. Okay, so that's what's going on here in this picture. So water specifically, we're going to talk about it just for another second because it's everywhere. It's 70% of Earth, it's 70% of your body. So water's boiling point is 100 degrees Celsius, or here in America, 212 degrees Fahrenheit. It's much easier to just talk about Celsius because it's easy and it's 100. So at that temperature, it will change from a liquid to a gas. It'll actually change into that steam. So what you're seeing here is water is boiling, it's turning into that steam, and then the vent down here is sucking it away so you can actually see it super easily. Okay, so all of this is superheated water that is escaping. Water's freezing point is 0 degrees Celsius or 32 degrees Fahrenheit. So in America, we say it's 32 degrees. Everywhere else, they talk about 0. It's much easier everywhere else, but here we are. So at that point, it changes from a liquid to a solid. So this is just one example, and they're using some funny magic. It's not really magic, but some funny magic to make this happen. They have the water super chilled. Basically, the water is at like 33 degrees. So when the ice cube comes in, it immediately starts to freeze everything. So it's pretty cool. I don't know the exact science behind it. That's the most I can give you, though. So water is the only substance that occurs naturally on Earth that exists in all 3 states of matter: solid, liquid, and gas. No other substance can reach boiling point or freezing point because the Earth just doesn't reach those temperatures. Some of these metals, it requires several thousand degrees in order to melt. That's never going to happen. We're the Earth. The hottest it gets is what, maybe 120? And that's in certain areas like Florida. And then some of them do not turn into a frozen, like if it's a gas, like oxygen. Oxygen doesn't freeze very easily at all. Okay, some other ones are better examples, but it's late and I'm struggling to think of some right now. So Earth can only sustain water at all 3 of these temperatures, or all 3 of these states. So down here we have solid as ice, here we have liquid as a lake, up here we have steam in Yellowstone Park. Another example of a gas would be a cloud. So you might want to make a note of that gaseous water can also be a cloud. The state of matter is determined by 2 things. One, it's how much attraction is between the atoms. So we sort of talked about this previously, where we talked about the solid particles. They're very strongly attracted to each other. And the liquid, they're attracted to each other, just slightly less. And then the gas particles, they don't really even care about each other. And another thing is the rate of movement. So how fast or slow things are moving. When you add coldness to something, when you chill something, it gets cold. Think about your body. If you go out in winter without a jacket on, you have to come inside and warm up before you can really move around too much. And you always warm up before you do anything athletic, gym class or sports, okay? You do those warm-ups because a cold body cannot move as easily as a warm body. So when ice melts, what's happening here is those particles, those water particles, can actually move around way more easily because they're not all frozen into that cube. Okay, so we're adding thermal energy or heat when that happens. Substances can also change states by increasing or decreasing pressure. And all pressure is putting force onto something. Your laptop is putting pressure down on the desk right now. If you're wearing a belt, that belt is putting pressure around your waist so your pants stay up. If you have a strict parent or guardian at home. They might put pressure on you to get perfect straight A's. Okay, so pressure exists in all different forms here. We're talking in physical pressure here, though. Okay, so take away that last example I gave you. Ice will actually melt if only pressure is applied, so no heat at all. So this little gadget down here, what it's doing is it's changing a rectangular piece of ice. It's scrunching it between two, I don't know, molds. There's no heat. This isn't a freezer. And just by pressure alone, it's turning it into a sphere. So I have a video that you're going to watch. It's linked to your Google Classroom to prove it. I think it's super duper cool because we all think that the only way to get through ice is to melt it, when actually you just need to push down on it hard enough and it'll actually start to melt, even if your hand is super cold. So when a substance changes states, its chemical properties do not change. So think of matter, iron. It's in a solid. It has rusting capabilities. But when it's melted, it still has those same chemical properties. It can still rust. Same thing with water. Frozen water is still water, just like water. I know I said water too many times. I'll say it one more time. What are you going to do about it? It is still colorless and odorless, whether it's an ice cube, whether it's a cup of water, or whether it is gas in the form of steam. It's still colorless and odorless. Some physical properties may change, though. Think about the blue jean example. If you're wearing blue jeans and then you go home and you scratch a bunch of sandpaper to it and you cut them off at your knees, they're still blue jeans. They're just a little different. You made them jorts or jean shorts. Okay, you cut some holes in it, you trimmed them down a little bit. So some of the physical properties just changed. So for example, what state of water is the most dense? Solid, liquid, or gas? So you may have said solid, but it's actually liquid. Liquid water is the most dense. Think about it. Ice floats on top of water. So a solid particle is actually floating on top of liquid water, which this is one of the only times this happens. Okay, most other things follow the rule that something that's solid is going to sink. It's more dense. But with water, what happens is when it freezes, those molecules, those H2O molecules actually move further away from each other. They get cold and they don't want to touch. So think about a full water bottle being frozen. If you don't even crack the top and you stick that water bottle in the freezer, you have a pretty good chance of it blowing up and expanding a little bit so that when you pull it out the next day, the bottom isn't perfectly flat. Maybe some of the ridges on the side aren't as deep as they usually are. And we have 2 slides real quick. So a mixture is when many different things come together. Think of mixing a cake together. Your backpack is a mixture. These 2 cups of water or liquid are a mixture. You're simply, exactly like the name says, you're mixing 2 items together. Each still has their own properties, so think of your backpack. Your folder is still a folder. Whether it's touching your reading book or your Chromebook, it still holds papers. Same thing here. That blue water is still blue, and the yellow water is still yellow, but when they mix together, they do in fact make green. And a solution is when one substance is dissolved completely in another. So salt water is a solution. If you get a sore throat, you're supposed to gargle salt water. And all you do is dissolve salt into water. The salt is still salty. Nothing has changed. And guess what? The water is still watery. You just simply dissolved that salt into the water. Everything maintained and retained its physical and chemical properties. Okay. One property of a solution, though, is that it has to be the same within, throughout all of it. Okay, if you don't mix the salt water in completely, like this guy on this slide, it does not make a solution. If he would stop right here, that's not a solution. He's got to mix it up with his little stirry rod first, and then it's a solution. So now he has a saltwater solution. So that's it for me for the day. Go back to Google Classroom to figure out where you need to navigate to next.